Hello, my name is Aileen Nielsen, and I am a New York City-based software engineer, and I work at a healthcare startup, and I am going to be talking to you about the main techniques, technologies, and data sources for healthcare AI. This video is an overview of the techniques and the data sources and is followed by 3 specialized segments also in this series. I'm going to begin by talking about coding for healthcare, why it's interesting, why it's taking off right now, and why you might want to get involved. First, healthcare is expensive, but there are obvious ways to improve. Everyone knows healthcare is expensive, especially in the US, and for that reason, healthcare applications are increasingly common, both in the consumer-facing space and the B2B space. And one thing that's been very interesting is with the takeoff of mobile health, there's much more customer-facing healthcare opportunities as people seek to put healthcare in their own hands. There's also obvious ways to improve because a lot of the system is centralized and is expensive. In 2016, US healthcare spending was more than $3 trillion, of which 32% was for hospital care and 20% for clinicians. What does this mean? There are 2 identifiable centralized sources where we can improve. One are hospitals. They're large institutions with centralized technology stacks ripe for reform. If you can reform one hospital or one hospital system, you are helping tens of thousands, if not hundreds of thousands of people. Similarly, doctors, the other main source of expense in US healthcare spending, do a lot of expensive but routine work that they would say they shouldn't have to do, and that isn't really interesting for them. Much of that could be replaced by AI in the form of physician extenders, and that's also a very interesting problem at the moment. So why AI in particular for healthcare? First, computers don't make the same kind of mistakes as clinicians. Clinicians get tired, computers don't. Medical mistakes cause billions of dollars in economic loss every year, and additionally, hundreds of thousands of people die every year from preventable medical errors, many of these being done by basic physician extender type personnel at the moment. So to the extent that these can be replaced by AI, that's very interesting, both economically and also safety-wise. Computers can scale also. Humans have limited focus. They can only do so many patients a day, and they can only do so many patients at a time, namely 1. Oftentimes, as healthcare costs rise, management tries to scale up doctors, but doctors don't really scale. The quality of the work and the clinician work satisfaction both suffer. On the other hand, AI does not have these downsides. It can scale and treat millions of patients at the same time. It doesn't suffer from fatigue or work satisfaction issues. Computers are reproducible. Humans can't always explain why they made certain decisions. Sometimes you will ask a clinician after the fact why they deviated from guidelines, and they can't remember, they don't know, perhaps they were tired, perhaps there was a good reason, but it's not documented. None of this is true when you work with AI. Humans are also not always rational, also not true for AI. AI is deterministic, reproducible, and for that reason also very helpful because you can improve since you can reproduce your steps. Finally, computers run all the time. There are known weekend mortality effects in healthcare. Right now, it's always better to get treated in a hospital on a weekday. When AI is running more of healthcare, we won't have this concern because AI doesn't have weekends and weekdays. In a perfect world, quality of care wouldn't depend on time of day of the week, or time of the year, but it does right now. This is something we can also change and improve upon with AI. More importantly, with the advent particularly of deep learning and of machine learning in the last 5 years, the last 10 years, there's more and more data-intensive techniques, and what's wonderful is that people are ready and willing to furnish healthcare data. So although healthcare data is traditionally considered to be very sensitive and private, in fact what we are seeing with healthcare startups is that people are very eager to improve their lives and improve their health by sharing their data. So for example, in a survey just in 2016, we found that 25% of Americans now own wearable health devices. The most popular are to track their speed and to track their heart rates. 60% of Americans are willing to share their health data with Google. That's a tremendous number of people, 60% of 300 million. The numbers are similar internationally, so there are millions of people happy to give up their healthcare data to get better health. And finally, more than half of all mobile phone users have downloaded a health app. Most users have said that they trust the accuracy of these apps and that they feel that these apps have improved their lives and their health. So people feel they are already realizing gains from sharing their data, which only makes them more willing to share data. There's also this new idea that information itself is medicine. And in fact, the FDA is leading the charge on this. The FDA reserves the right to regulate health apps. What can be done right now, say in the startup sector with healthcare, is as much a legal question as a technical one. AI is ripe to apply to healthcare, but sometimes it's the FDA stepping in and saying that we need to find the right balance of what's appropriate. So things that might be riskier or target more at-risk populations tend to be more highly regulated. For example, an insulin dosing calculator, an app used for contraception, or a mobile app that is having any sort of real-time sensor, that's going to be a highly regulated application. It doesn't mean you can't do it, but you will have more regulation. Potentially regulated apps that are more in a gray area are things like apps that might provide periodic reminders to pregnant women, so a vulnerable population, but the information they're getting is probably more benign, or mobile apps that are seeking to use games to encourage people to do physical exercise at home. So this idea that even just by telling people something, you are providing medical treatment or a medical device in some cases is certainly taking off. So as AI is growing and having more potential, the regulation is also growing. Right now, everyone is agreed in the healthcare space that the biggest challenge is bad data. Electronic health records, which are often just referred to as EHR, were originally built for billing, not for big data. The secondary purpose has traditionally been for clinicians to transmit information to one another, but they'll also usually do this in free-form text notes. So the billing tends to be in these very complicated medical codes, and then clinicians talking to each other tends to be in free-form handwritten information. Electronic health records are also used for lawsuits, so there's all sorts of non-data-driven, non-AI-driven reasons that information is collected, and it's only now that healthcare organizations are beginning to think about how they can reshape these for AI. There's also an accuracy problem in the data. So apart from the fact that the data is not crafted for AI purposes, and apart from the fact that the data is often just in free-form handwritten notes or free-form typed notes, there's also the case that many codes are not accurate. When you go in for treatment, your clinician might mark you with something which is a best guess, a possibility, or something they want to eliminate, even though it's a low probability case. The problem is often that code will stick with your medical records. What that means is something like 80% of patients marked with gastric cancer don't have cancer, or 50% of patients marked with cardiac arrest are not actually suffering from cardiac arrest. So these records are sort of notably inaccurate, which is a big problem for machine learning and AI. Also, healthcare is an extremely conservative industry, so organizers are reluctant to change their technology stack. They have a centralized technology stack. It's very tempting for AI to reform it, but because of the nature of the industry, this won't always happen. The good news, after all this bad news, is that you don't actually need big data to make a big difference in healthcare right now. For one thing, there's very strong signal, and for another thing, because so little has been done, even a first pass getting good accuracy is already great. So this is not a problem like ImageNet where you're going for 99.5% accuracy. Lower accuracies are already an improvement. And just to get you excited, some recent applications of AI in healthcare: Japan's robot bears to cope with inverted population pyramids. There aren't enough young people to nurse the older members of the population. The Merck drug discovery challenges are nowadays, for the last 5 years, dominated by people who don't know anything about drug discovery but only know about neural networks. So that's really interesting as an AI researcher in healthcare. And finally, startups are starting to do cool things like individualized health plans based on health indicators. So there are things happening right now, although there could be a lot more. And finally, just some notes on working with clinicians, what I've learned over the last few years working with doctors. Analytical clinicians think in Excel, so they're going to be amazed at what you can do if you're fluent in R or Python. Just very fast data transformations that can take them hours. That will blow their mind. That said, they will usually stick to the analysis they're able to do in Excel. So you usually, when you are working with clinicians, need to sort of push them to new techniques and explain the new techniques because it's not something they are naturally exposed to. Non-analytical clinicians think in case histories, and you will also work with people who are sort of less analytical and less exposed to these ideas about AI and big data. So usually you want to remember they work in case histories and try to make analogies that way for them. And finally, clinicians come from ponderous working cultures. They're used to decision by committee, concerns about ethics and total correctness, and they're often unaware of the limits of their own data. So sometimes you'll also find that they expect magic once they have come over to the realm of big data. So these are good things to be aware of as you begin relationships with clinicians. So that is the end of the first segment, and now we will talk about building healthcare data pipelines.